Okay, so we're going to look at some examples here and then we'll go over the rest of these in class. So this comes from the second set of notes, and what I want to focus on right now is let's look at this example here where it says circle whether the following is a true statement or a false statement. So let's do A, D, and E, and that's based on this image here. Now the first statement says the measure of angle 1 plus the measure of angle 11 equals 180 degrees. We want to decide if that's true based on the image we're given. Well, notice we're given a set of parallel lines here. So this guy and this guy is parallel. And we also know that this guy and this guy is parallel. Okay, so we got to use that, keep that in mind as we're going through this information. Now, angle 1 and angle 11, let's just spot those guys out. Here's angle 1. And here's angle 11. I'm actually going to use a different color because we don't know if they're the same or not. Right now, all we know is these are the two angles that we're looking at. And we want to know if those two angles, if I add their measures together, if it equals 180. Well, to help us out here, notice that angle 11 is right next to angle 9 here. Okay? Now, if we go back to what we talked about in one of the previous sections, we know that this angle 11, and this angle 9, what do those guys form? Vertical angles, right? They form vertical angles, and specifically since they form a straight line, they form a what? A linear pair. What do we know about linear pairs? They're supplementary, right? What does supplementary mean? They add up to be 180 degrees. So the measure of angle 9 plus the measure of angle 11 adds to be 180. Okay, so those guys add up to be 180 degrees. Okay, now also notice angle 1 and angle 9. What type of angles are those? Well, they're corresponding angles, right? Isn't this line, let's use the same color here, isn't this line and this line parallel? Yeah. So this would be the transversal, and since those guys are on the same side of the transversal, one's on the inside, one's on the outside, those guys are corresponding angles. What do we know about corresponding angles? They're congruent. We know that angle 1 is congruent to angle 9 here, which means they have the same measure, right? So if that's the case, then the measure of angle 1 plus the measure of angle 11 also equals 180 degrees, okay? Since angle 1 and angle 9 are congruent, and we know that these two are supplementary, that means angle 1 and angle 11 must also be supplementary, add up to 180, okay? So that is a true statement, okay? Let's look at D here. So it's asking a similar question. It says, is the measure of angle 6 plus the measure of angle 11 equal to 180 degrees? Okay, so we know where angle 11 is. Let's find angle 6. Well, angle 6 is up here. Okay, now we want to decide if those guys add up to be 180 degrees. Well, let's just kind of take an exploration path here and see if we can figure this out. Okay, well, notice here, again, using these same lines, these guys are parallel, so this would be a transversal. Okay, now I'm going to use a similar argument to help us figure out what's going on here. Notice, trying to get the right color, notice that angle 6 and angle 14, what type of angles are those? They're corresponding angles, just like angle 1 and angle 9 were corresponding angles. What do we know about corresponding angles? They're congruent and have the same measure, okay? Now, also notice, isn't this line and this line parallel? Yes, if that's the case, then this is a transversal for those two lines. Well, what does that help us do? Well, notice angle 10 here is angle 10 and angle 14 corresponding angles. Yes, they're also corresponding angles. So far I know this. Angle 6 was congruent to angle 14, okay? Angle 14 is congruent to angle 10 because of corresponding angles. And then notice, what's the relationship between angle 10 and angle 11? Those are vertical angles. Well, based on the vertical angle theorem, what do we know about those guys? They're also congruent. So angle 10 is congruent to angle 11. Well, based on what we know from all of this, what do we know about angle 6 and angle 11? Well, this is almost like the transitive property, right? Take out the middle man. Doesn't that mean that angle 6 is congruent to angle 11? Yeah. So angle 6 and angle 11, those guys are congruent. So do they add up to be 180 degrees? Not necessarily. The only way that would work is if they were what? They'd have to both be right angles. So it's not necessarily true, so this would be false. Okay? We don't know. The only way this would work is if they both happen to be right angles, which would mean that they're congruent to each other, but they're also supplementary. Okay? What about 10 and 13? Okay? Well, 10 was right here, and 13 is right here. Now I'll use a different color. Let's do pink. Why not? So 10 and 13 are right here. Well, what type of angles are those? Well, that's same side interior, right? That's same side interior angles. What do we know about same side consecutive interior angles? They add up to be 180 degrees, okay? They're supplementary. So in our example here, it's asking us, is angle 10 congruent to angle 13? Well, the only way that they can be congruent is if they're both what? 90 degrees. So that's kind of like what we were talking about here. They could be congruent, but the only way that that would work is if they're 90 degrees, because they also have to be supplementary. So we know that same side interior angles here, these guys right there, they have to add to 180 degrees. So the only way that they can be congruent is if they're both 90 degree angles. So is that a true statement? Well, we don't know. We have enough information to say that it is true, so this would be false. Okay? They don't have to be congruent. The only way that would work is if they're 90. Okay? Now, the next thing I want to look at is using this image here to mark out which one of the angle pairs, goes here with the angles that were given. So we have angle 2 and angle 12 here. So it says angle 2 and angle 12. Well, I'm going to try to clear things up a little bit here. I know we kind of wrote all this nonsense in here, but I'm going to try to clear this up so we can kind of see what's going on. Okay? So now we have angle 2 and angle 12. What type of angles are those? Okay, well, notice they're on the same side of this transversal here, right? They're on the same side. However, they're on the outside of these two lines, okay? So those guys would be called same side exterior angles, number 5 here, okay? Same side exterior angles. They're on the same side, but they're on the exterior, okay? What would 7 and 15 be? Well, 7 is here, 15 is here. They're on the same side of this transversal. However, one's on the inside, one's on the outside. What is that called? Corresponding angles. So that's 1. Okay. Then we have 5 and 6. Okay. 5 and 6. Well, we kind of talked about an example earlier. Those two angles form what? Adjacent angles, specifically a linear pair, because they form a straight line. So those guys would be a linear pair. Okay, 9 and 16. 9 and 16. So we have 9 and 16. Okay, now those guys are on opposite sides of this transversal. So they're on alternate sides of this transversal, but they're on the exterior there. Okay, what would that be called? Alternate exterior angles. Alternate exterior angles. Use black. There we go. So alternate exterior angles. Then we have angle 13 and angle 12. Okay, angle 13, there you are, and angle 12. Well, those guys, they're on opposite sides of this transversal. They're on alternate sides. However, they're on the inside of the two parallel lines. So what would that be? Alternate interior. Alternate interior. So that guy is number 2. Okay, so alternate interior angles. Then we have 7 and 13. Well, let's use pink. Why not? So we have 7 and 13. Now, those guys are on the same side of this transversal. Okay, however, they're both on the inside here, on the same side on the inside. What would that be called? Well, we looked at an example earlier. That's same side interior angles. Same side interior angles. Okay, so we used up everything here. We have 1, 2, 3, 4, 5. The only thing we didn't use is vertical angles. An example of that might be like angle 14 and angle 15. Those guys are vertical angles. Okay, then I also wanted to look at an example here. Let's look at example 3. Okay, it says if the measure of angle 4 is 35 degrees, we want to find these other measures. So the first one it says is the measure of angle 11, or not 11, angle 1 here. Well, notice, what are angle 1 and angle 4 making? Vertical angles. What do we know about vertical angles? They're congruent. So if angle 4 is 35 degrees, angle 1 is 35 degrees. Okay. So then we also have angle 3. So now we're looking at angle 3. Now, we knew that this was 35 degrees because of the vertical angles, and we're trying to figure out what angle 3 is. Well, notice, what does angle 1, let's see if I can line this out, angle 1 and angle 3 make? Aren't those adjacent angles? Don't they form a straight line? So that's a linear pair. What does that mean about angle 1 and angle 3? They're supplementary. In other words, they add to be 180 degrees. So angle 3 plus angle 1 here has to add to be 180. We'll take 180 minus 35 and we'll get angle 3. What's 180 minus 35? 145? Okay. So angle 3 here, there we go, is 145 degrees. Okay. 145 degrees. Then it says angle 5. Okay, well, angle 5 is over here. Well, notice, isn't angle 3 and angle 5 alternate interior angles? Those guys are congruent, right? Alternate interior angles are congruent, so if angle 3 is 145 degrees, angle 5 is 145 degrees. Okay? Then it says angle 13. Angle 13 is over here. Now, look closely at this. We have parallel lines here and here, and we've been using this transversal. Isn't this guy a completely and totally different transversal to these parallel lines? Yes. So this has nothing to do with all the angles happening here. Nothing at all to do with these angles over here. So in other words, we don't know what angle 13 is. It could be something completely different because it's cut by a completely different transversal. There's no way of telling what's going on over here. So that would be a good way to write it would be not enough information because we don't know, or you could say NEI, not enough information. Okay? Angle 6. Well, notice again, we have a linear pair situation. We have adjacent angles with angle 5 and angle 6. Adjacent angles that form a linear pair. We know linear pairs are supplementary. So angle 5 plus angle 6 has to add to be 180, right? That means take 180 minus 145 and we get angle 6. Well, what's 180 minus 145? 35. Another way you could have looked at it is, isn't angle 4 and angle 6 alternate interior angles? Yeah, so they have to be congruent, right? So we would still get 35. It's just another way to look at it, okay? So we have angle 6 is 35 degrees, then angle 8. Well, again, we could use a linear pair with 5 and 8, but we could also use vertical angles. We have angle 6 and angle 8, they're vertical angles. So vertical angles, these guys are congruent, 35 degrees. Okay? So the next thing I want to look at, I'm actually going to go on to the second example, so that second notes page. And I want to go all the way towards the bottom, 21. Let's see, is that the one I'm looking for? That's not the one I'm looking for. Well, we're going to go ahead and use this anyways. This wasn't exactly what I was looking for, but we'll go ahead and use one of these examples anyways, okay? I just want to talk about how to work through a couple of these algebraic examples with you guys, okay? Let's see if we can find a good one here. Let's look at number 25, okay? So let's look at number 25. Now, in this example here, we're given these set of parallel lines, and we're cut by this transversal. Now, what they want us to do is find x. So we have to use our knowledge of how the angle pairs work in order to solve for x. Well, notice, isn't this angle here and this angle here, aren't those guys alternate interior angles? Yeah, what do we know about alternate interior angles? They're congruent, right? So they have the same measure. So if this guy is 14x plus 13, then this guy is 14x plus, or not 13 plus 3. Sorry, excuse me. So if this guy was 14x plus 3, then this guy also has to be 14x plus 3 because they're alternate interior angles. Well, notice this is parallel to this. This is on the same side of this transversal. What do we call these guys? Those guys are corresponding angles. What do we know about corresponding angles? They're also equal. They're also equal. So now if we want to find x, we know that this guy equals this guy. What can I do with those two? Set them equal to each other. Their measures are equal. We can solve for x. Okay, so now solving for x, let's move our x's together. Minus 14x to both sides. Inverses cancel and we get 3 is equal to 1x or just x minus 3. Add our 3 over and we get 6 equals x. Okay, so we're doing the same thing, it's just we're solving for x. Let's see if we can find another example to look at. This one would be a good one. So on the last example, we set them equal to each other because they were congruent angles. In this one, we have parallel lines, okay? We have parallel lines. What do we know about these guys right here? They're same side interior angles, right? What do we know about same side interior angles? They add to be 180. They're supplementary. So 75 plus 15x has to equal 180 degrees. They have to add to be 180. Well, again, we can solve for x. I could subtract... Whoops, there we go. I could subtract 75 from both sides. Okay, and we get 15x. Carry this out. We get 10, 5, 0, 105, right? So we get 15x is equal to 105. Well, then opposite operation, what do we do to both sides? Divide by 15, and we get x is equal to 7. Okay, so we get x is equal to 7. Okay, so this is just a couple of examples that we can run into that are algebraic.